Welcome to this lesson where we are going to discuss an arithmetic series. One formula you'll need to remember and have written down in front of you is from our arithmetic sequence, in which we have a sub n equals a sub 1 plus parentheses n minus 1 times d. You will want to have this formula handy because we will use it before we are able to plug it into our arithmetic series formula, which is as follows. So to find the sum of the first n terms of an arithmetic series, we have the formula s sub n equals n times, with that parentheses, a sub 1 plus a sub n, all divided by 2. So take a minute, write this formula down, and we will dive into our first example. First type of example you will see, the question will ask you to find the indicated sum for each series. Example 1, we want the sum of the first 15 terms. When it says the little 15, that means we want the sum of the first 15 terms of this arithmetic sequence that starts out as 25, 12, negative 1, negative 14. The very first thing we need to do is find the common difference. And the common difference, in order to find it, we need to take the second term of the sequence and subtract it with the first term of the sequence. 12 minus 25 would give me a negative 13. We could have used any numbers of the sequences. I chose to use the second term minus the first term. You'll notice, since it's arithmetic, if we did the third term minus the second term, negative 1 minus 12, we would also get the same common difference of negative 13. Once we have the common difference of d equals negative 13, we need to find the 15th term in the sequence. To do that, we need to remember how we found the 15th term from our arithmetic sequence from our previous lesson, where we need this formula identified early in the video. A sub n equals a sub 1 plus n minus 1 times d, the common difference. So in this case, we want to find the 15th term. The first term of the sequence is 25, so I'm going to replace a sub 1 with 25. N in this scenario, since we are trying to find the 15th term, n is 15 minus 1. And the common difference we found on the previous page is negative 13. So whenever I multiply by a negative, I put it in parentheses so that I don't confuse myself. If I were just to put times minus 13, I might think that was just saying subtract 13. When we multiply by a negative, we always want to surround it with parentheses. So when we calculate this, 25 plus 15 minus 1 is 14. Well, 14 times negative 13, we would do that first. And we would add 25 to it, and we would end up with negative 157. Once we have the 15th term, now we are ready to plug it into our summation formula from the very beginning. Our s sub n equals n times a sub 1 plus a sub n, all divided by 2. We are going to use the 15th term, and I'm going to be able to plug that into the formula right where a sub n is. So we want the sum of the first 15 terms. Well, that's going to give us, well, n in this case is 15, so replace the n with 15, times the first term of the sequence is 25, plus we've had to find a sub 15 on the previous page, negative 157, all divided by 2. Now it's very important to remember that we have to do the top addition part first. I have to do the 25 plus a negative 157. That will, oops, can we get the pen out? That would give us negative 132 divided by 2, and we multiply that by 15. So negative 132 divided by 2, that gives me negative 66 times 15, and our S sub 15 is going to equal negative 990. That is the answer we are looking for when we are trying to add the first 15 terms of this sequence. Example 2 is going to look a little bit differently. We still want to have our formula in mind, where S sub n equals n times a sub 1 plus a sub n divided by 2. Where in this case, for the formula to work, we need the first, and this a sub n always represents the last term of the sequence that we need. For example 2, that is our sigma, that is our sum symbol from the first term to the 12th term. So in order to plug these into our formula, we'll first need to find the first term. And this, if you remember from our previous lesson, is an explicit sequence. So if I want the first term of the sequence, I'm going to plug in a 1 for that k. So the first term is going to be 3 plus 4 times 1, which is 7. Then we want to find the 12th term. Well, instead of a 1 for the k, now we want the 12th term. We're going to plug in 12 for k. So 4 times 12, that gives us 48, plus 3 would give us 51. Now that we have the first term and the last term, we can plug it into our summation formula. I'll use a different color here. So to find S sub 12, the sum of the first 12 terms, n is 12, we can plug it in there. The first term of this sequence is 7, plus the last term of the sequence is 51, all divided by 2. Now remember, as you're figuring this out, we have to do the top part addition first. So this is going to be times 58 divided by 2. And we can, since that division's in parentheses, we can take care of that first. 58 divided by 2 would give us 29. Multiply 29 by 12. And the sum of the first 12 terms of this sequence is 348.